Hello viewers, back again with another topic, very important topic of class 12, linear programming problems, both for CBSE as well as ISC. Once again, thanks for subscribing my channel and giving lot of comments about my performance. I'm trying to improve a lot. I don't know how much I have been able to uh, be up to your expectations. Anyway, I'm trying my level best. Now, linear programming problems. This word programming does not mean anything related to programming of computer like C++ or Java or Oracle or something like that. Well, this linear programming problems are problems in mathematics where the statement problems are converted into say mathematical models or mathematical equations, linear equations and linear inequalities. So suppose we have a problem like, for example, a manufacturer manufactures a product, and obviously when a manufacturer manufactures a product, he would like to maximize his profit. He would like to get the maximum of profit from his production. So his main objective is to make his profit the highest. But I just what I told that maximize. I have some objective. This is my objective. My objective is to maximize to the greatest. Maximize what? In this example which I told, profit. Every businessman likes to maximize his profit, but always the expectations are not reached of getting the profit. More and more profit they want. But why? Because there are lot of restrictions in his manufacturing. For example, he may be having the restriction of his capital, he may be having the restriction of his labor, he may be having the restriction of the product quality, he may be having the restrictions of the raw materials, and many more. So there are some variables on which the maximization of the profit depends. So that variables we are supposed to calculate in order to know what will be our ultimate maximum profit or whatever maximum objective is based on the restrictions. So whenever we have a problem of in real life situation, we know what is our goal. Our goal is to maximize, or sometimes it is minimize also. When it is minimize, suppose a manufacturer produces some products and he wants to transfer his goods to a distant place. Whenever he wants to transfer his goods, he needs to see whether the transportation cost is the minimum cost. If the transportation cost becomes minimum, then obviously his cost of production, which will be included in the transportation cost, becomes lesser and lesser. If the costing is less, then his profit will be more. So in that case, he would like to minimize his cost of transportation, or he may like to minimize the loss of the company. How much? Sometimes the market conditions are not so good, so he would like to sell off the goods in the lower price of the than the cost price, so that the loss is minimum, beyond which we cannot go. So the loss he wants to always minimize. So this is what our objective is. Objective can be maximized or objective can be minimized. Now we have some restrictions. This restrictions we say as subject to. Subject to. Subject to what restriction? Subject to that maybe there are two types of raw materials required for preparation of the product. The raw material A or B, we name it. Remember, raw material A and B. Maybe raw material A we can give only say 100 grams per unit, and raw material B maximum we can give 200 grams per unit. And suppose we have the cost of raw material A is say 5,000 rupees, and the cost you can spend on raw material B is maximum 7,000 rupees. So these are the restrictions which are there in the problem. So those restrictions have to be kept in mind so that the profit is maximum. This is the idea about linear programming problem which I would like to introduce. Now, in order to understand the linear programming problem very well, we should have a very clear-cut idea about plotting of the graph and shading the areas where the solution lies. Means we have another definition or another very important thing to understand, that is the feasible reason. Feasible reason. What is this feasible reason? Suppose when we are plotting the lines on the graph, the region which gives us the feasible portion or the solution area which will give us the solution of the problem. What is that? Now to understand that, let us understand the concept of inequality. For example, we have an inequality, say x plus 2y less than 0. Now, or less than, say, let us take 6, less than 6. X plus 2y is less than 6. Now, for the time being, let us forget that there is an inequality. What let us think of? Let us think that x plus 2y is equal to 6. Obviously, this will be representing a straight line. So that means y is equal to minus 1 by 2 x plus 3. That means minus 1 by 2 is the slope of the curve, and 3 is the y-intercept. So the curve or the straight line will be somewhat like this. So this is y equal to minus half x plus 3. This is 3. 0, 3. Now, this is the straight line. Now let us come back to the inequality. X plus 2y less than 6. Now, it's obviously that y is equal to minus half x plus 3 are all the points on the straight line. This one, that is x and y, always lie on this point. But what about this inequality? This inequality shows that all the points x, y which are less than 6 satisfying this inequality. So how to know which portion are those? For that, x plus 2y. So the rule is we take a point on any side of the line. This line divides the plane into two parts, the upper half and the lower half. So we have points over here, plenty of points. We have plenty of points over here. Now, maybe there are a lot of points here, but one point which is very clear to be visible to us, that is 0, 0. So, if I take the point 0, 0 and place it in this inequality, we will get 0 plus 0, which is less than 6, or 0 is less than 6. Now, 0 is less than 6 is obviously true statement. It is a true inequality. So, since it is true, we shade the portion towards 0. But we don't touch the line. So, we give a shaded or a dotted line. We give a dotted line that which shows that the line, all the points x, y which are below the line y is equal to minus half x plus 3, but not on the line. If the same inequality had equal to sign, then we would have drawn from the line. This is how we shade the portion which of xy which satisfies a given inequality. So this concept will be helpful for us to solve the problems of linear programming problem by graphical method. There are plenty of methods of solving a LPP, but graphical method is the only one which we have in our syllabus, and we shall understand this in our next video. Let us wait for the example.